Okay, well, you can start anytime.
Thanks, Ted. Well, we'll go ahead and get started. Welcome, everyone. My name is Paul Hazlett. I'm a volunteer with the Sioux Climate Hub. I'm going to be moderating tonight's webinar. I'd like to begin by acknowledging that we are in the Robinson-Huron Treaty Territory and that the land on which we are gathered is the traditional territory of the Anishinaabe, specifically the Garden River and the Bechuana First Nations, as well as Métis people. Before we get going, I just want to tell you a little bit about the Sioux Climate Hub. We are a nonpartisan group of concerned citizens advancing climate change mitigation and adaptation to align Sault Ste. Marie and Algoma with scientific, aspirational, and global targets for greenhouse gas emission reductions. And we aim to do this, and we do this through education, engagement, and action. The Sioux Climate Hub is part of the Climate Reality Project Canada that serves as the Canadian component of the global movement of more than 21,000 diverse and dedicated volunteers from 154 countries. If you are interested in following our activities, signing up for our quarterly newsletter, or joining the Hub as a volunteer, you can check out our website that you see there on the page. You can find us on Facebook and Instagram as well, and you can email us. We welcome everybody to be part of our group. We're excited to be back tonight for the first of 3 webinars that we're going to be hosting this fall. I'd like to let you know too that you can find all of our previous webinars on our YouTube channel, and keep our eye on social media for our October and November webinars that are coming up. For tonight's webinar, we're also happy to welcome participants from the Climate Reality Project Canada, and we may also have some attendees from other climate hubs across Ontario. Following the presentation and the question and answer period tonight, everyone's welcome to stay on for another 30 minutes or so when Ashley Anthony from Climate Reality will lead a conversation on community updates and intel sharing among hubs. Tonight, we're really happy to welcome John Pedlar, a forest biologist with the Great Lakes Forestry Center in Sault Ste. Marie. Lots of you will know it as the Bug Lab. It's affectionately known as that in Sault Ste. Marie. It's one of 5 federal government research centers that are part of Natural Resources Canada, the Canadian Forest Service. While the priorities at the Bug Lab do include bugs, researchers there also study the impacts of forest management, wildfires, and climate change on forests and people. John's presentation tonight will summarize recent efforts by researchers at the Great Lakes Forestry Center to update Canada's plant hardiness zones. Because this work shows that Canada's climate has changed significantly over the past century, and that these changes will affect how forests, crops, and gardens will survive and grow, it's garnered a lot of media attention since the work was published earlier this year. So I'd like to turn it over and welcome John. Thanks for being with us tonight.
Thanks, Paul. I'm just going to go ahead and share my screen, which has been a little bit of an adventure when we've tried doing this in warm up. So does that look okay?
That's good.
Okay, great. Okay, well, hello everyone. It's great to be here tonight, and I'd like to say a special thanks to Paul for persisting and inviting me and keeping on me to make this happen. So today I'll be talking about updating Canada's plant hardiness zones and assessing change over time. And I'd like to recognize the contributions of the co-authors on this talk who have helped with this work. Listed here, Dan and Kevin and Caitlin and Heather, and certainly a big shout out to Dan, who's really headed up this work for coming on 3 decades, although he doesn't like to admit that it's been that long. So a bit of an outline plan for tonight. I'm going to start with some context and history on the project on plant hardiness mapping in Canada. Then we'll talk about the updated plant hardiness zone map and some of the changes in hardiness zones over time, and finish off by talking about some of the future of hardiness zone mapping, some of the projects we have on the go, and some concluding comments. So what are hardiness zones? I thought in case some of you weren't really familiar with hardiness zones, I thought we should start by just sort of talking about what they are. So basically, they're areas with a unique set of climate conditions. And in the case of the Canadian plant hardiness zone system, there's 7 different variables involved. We'll go into those in more details in later slides. But when I talk about unique conditions, I'm talking about with that set of 7 climate variables. And operationally speaking, there's 10 zones in Canada, 0 through 9, and each of those is subdivided with an A or a B. So we get 0A, 0B, 1A, 1B, etc., right through to 9A, 9B. And given the close links between plant survival and growth and climate, it follows then that each of these hardiness zones has a relatively unique set of plants that grows there as well. And I guess the real value of these hardiness zones is that in combination with ratings shown on plant tags at garden centers, it as long as gardeners know what their zone is, it's a relatively simple system to help them know what plants should grow well in their areas. I should clarify that let's say you're in a zone 5, you don't necessarily have to have only zone 5 plants growing in your garden. Typically, plants rated lower than your zone will also grow there fairly well. So for zone 4, zone 3, zone 2. But when you start trying to grow plants that are rated higher than your zone is when you can get into trouble. So growing a zone 6 plant or a zone 7 plant in a zone 5 location could be challenging. So we think about hardiness zones in the context of gardening. That's certainly where they're used the most, but really any situation where you're planting and maintain a perennial plant, so plants that come back in the same location year after year, could and do make use of hardiness zones, and that includes things like orchard crops and agricultural crops and landscaping and forestry as well. So hardiness mapping in Canada really started in the 1960s with the seminal work of 2 Agriculture Canada researchers by the name of Charles Willett and Lawrence Shirk. And what they did was they established a nationwide trial that involved 174 different ornamental trees and shrubs, species and varieties, and at 108 locations across the country. And the map I'm showing here just shows a sampling of those locations and species. I've sort of organized the species with shrubs on the left side and trees on the right, and the more hardy species at the top and the least hardy at the bottom. And you can see there was quite a range in terms of the hardiness of those species. I mean, from blue spruce and white pine, right through to silk tree, which is quite a warm climate species. And as far as shrubs go, from things like common lilac and North cedar, which are quite hardy, through to rhododendrons and the California lilac there. So from that trial, Willett and Shirk gathered information on the survival of those different species at those locations, and they developed a number of different statistical models, basically regression models. And this was back in the 1960s, so it wasn't as easy as it is today to run these regression models. But credit to them, it was good work and it stood the test of time. And they developed a number of these different regression models, but the one they settled on was one that involved 7 climate variables. And this is then the basis for the plant hardiness calculation in Canada. And we'll just go over these variables. So the first one is the average minimum temperature of the coldest month. The second is the length of the frost-free period. The third is rainfall from June to November. Fourth is average maximum temperature of the hottest month. The fifth is a rather strange variable called winter factor, which we could probably spend half an hour trying to puzzle through and talk about, but I'm just going to suffice to say it's a combination of the amount of rainfall in January, not precipitation, but rainfall, and that's multiplied by the average minimum temperature of the coldest month. So you're getting at a situation there where you're talking about areas that have like warm spells in combination with cold temperatures. The sixth variable is minimum or maximum snow depth, and the seventh is maximum wind gust. So quite a variety of variables, but all kind of clearly related to plant survival. And it's important to keep in mind that these are long-term averages, that the original work by Willett and Shirk involved climate averaged over a 30-year period in their case, or I guess technically 31, 1930 to 1960. And I've shown the final model there just so you can actually see it. I mean, if you have each of these 7 variables, what you would do is simply multiply through by the coefficients for each variable shown here, and you would end up with a hardiness index value for your location. Now, going to go into a little bit more detail, maybe more than you want to hear, but there is one more step here, and that is that you have to take that hardiness index value, which is a number, but typically between 0 and 100 in Canada, and you need to convert that into the well-known hardiness zone, 0A, 1A, 2B, etc. So in order to do that, the zone number is taken from the tens value of the index. So for example, if you've calculated an index value of 54, say, well, the 50 part of that number indicates zone 5. So you're in zone 5, and then to get the subzone, the A or the B, you're simply looking at whether that 1's value is greater than or less than 5. So in this case, 4 is less than 5, so you are in a zone 5A. And I've shown in the table here, the full list of index values and how they would convert into hardiness classes. It is really quite straightforward, but you might be wondering why I'm going into this detail, but it is kind of important for understanding changes over time. A lot of times we'll get people say, hey, what's going on at my location? I know there's been warming going on, but my zone hasn't changed. And sometimes what happens is you do get an increase in the index value, but it just isn't large enough to actually move it over into the next zone. So for example, you might have had an index value of 50 at one update, and then at the next one, you've got an index value of 54.9, but those are still kind of convert over to zone 5A, even though you have had a change in your index value. So back to Willett and Shirk. They then used that formula we talked about in the previous slide and calculated the hardiness zone values at 640 weather stations across Canada, and then they hand interpolated the final maps. And these are some examples of the maps that they came up with some more than 50 years ago now. Those maps were digitized at some point by Agriculture Canada, I think in the early 1990s. And to be clear, these were simply that they were digitizations of the original maps. They weren't updates per se with new climate data, but they did make them available via computers. So it was in the mid 1990s then that there was a bit of a shift in hardiness zone modeling in Canada. That was when Dan McGenney's group at GLFC started to develop climate models for Ontario and for Canada. And Dan had done his PhD in Australia at the Australian National University, and one of the people he met there was Michael Hutchinson, who was a mathematician and climate modeler who developed a software package called AnnuSplin that used kind of fancy math, thin plate smoothing splines to basically take climate station data, so point data from across an area, and then interpolate and smooth and extrapolate that data to come up with a smooth surface, or essentially a map of climate. And Dan was one of the early people in Canada to be making maps of climate. And I've heard him tell the story that, one day he was in his backyard doing some gardening and he looked at the back of a seed package and saw the plant hardiness map there and a little description of the variables, the climate variables involved. And he realized, hey, we could actually do this in our lab. And so that was really the epiphany, I guess, that started down the path of plant hardiness modeling at Great Lakes Forestry Center. And so a few years after that epiphany, in 2001, the first plant hardiness zone map update in over 30 years was generated. This was using climate data that covered the 1961 to 1990 climate period. And part of that work was actually using climate data from the original climate period that Willett and Shirk had used to see if we could generate a map that approximated their original map. And we did feel like that we were able to do that, and that's how we felt sort of confident moving forward with the approach that we had. I want to talk a little bit about the US plant hardiness map, which was also updated for the first time for Canada at the same time as that update of the Canadian system in 2001. And the USDA map is quite different from the Canadian approach in that it relies on a single climate variable, and that is average annual extreme minimum temperature. So think of a location, think of the coldest temperature that's measured there over the course of a year, and then average that over your time period of interest. So in this case, it was 1961 to 1990. And the reason I bring that up is that there's often confusion as to which system is being shown on the plant labels in Canada. Sometimes it's based on the US system, and sometimes it's based on the Canadian system. And in 2006, we did a study comparing the two systems to see if there was a simple conversion that could be used. If you're a 5B in Canada, maybe it just means you're a 5A or something in the USDA zone. But that didn't seem to be the case. And I've shown a table that kind of summarizes the main findings from that study. I know there's a lot of numbers here, and I'm not going to go into a lot of details, but just for an example, let's say we look at Canadian Zone 4A, and when you overlay the USDA map, you find that there's actually 9 different USDA zones that intersect with Canadian Zone 4A, and some of them quite heavily. So it's really tough to simply make a simple rule of thumb about converting between these two different products. So it is a bit of a confusion, and I would mention that at our plant hardiness website that I'll talk about shortly, we do provide both the Canadian map and the USDA map for Canada, so that people are able to figure out what their rating, what their hardiness zone is under both of those systems. So as long as they know which system is being shown on the plant labels, they can still get some good guidance about what to plant at their location. So a second update then happened in 2014, and this was using climate data that covered the 1980 to 2010 period. And this update focused a bit more on change over time. I'm not going to go into a lot of details on change here because I'm going to kind of focus on that more with the most recent update. But we did produce difference maps such as the one shown here, and this was showing zone changes between that 2014 update map and the original map developed by Willett and Shirk, and anything in red is an increased zone. So you can see that clearly much of Canada had increased. And there were other signs of increase, for example, the appearance of Zone 9A for the first time in Canada in far southern British Columbia around Victoria. But that brings us then to the most recent update, which was in July 2025. And the climate data for this map covered the 1991 to 2020 period. And it's worth repeating that, this was still using that original formula developed by Willett and Shirk, and simply applying updated climate data to that formula. So as I mentioned, we did a bit of a deeper dive into changes over time in this update. And so we focused on change between the current update, so for the 1991 to 2020 period, and the original update for the 1961 to 1990 period. So basically a 30-year change. And what we found was that much of Canada, particularly southern Canada, south of about 60 degrees, 80% of Canada showed an increase in its hardiness zone. About 20% was unchanged, and less than 1%, a very small fraction, had actually declined. To do a bit more regional explanation here, the biggest changes were in Western Canada, particularly southeastern British Columbia and the foothills region of Alberta. Those areas showed increases of 2 full zones in some locations. Also up in the northwestern portion of British Columbia, there were large changes. And even in northwestern Ontario, there was a bit of a hotspot around Lake Nipigon where changes of up to 1.5 zones were observed. The largest decline, which isn't a very big decline, but still you can see the sort of bluish coloration in eastern Newfoundland. And that was probably the biggest area of decline in the country. And our going theory on that is that it's kind of one of those counterintuitive outcomes of climate change, in that we've looked at the data and there was a higher number of icebergs spawned in the North Atlantic in the later time period, the 1991 to 2020 period. And the thinking is that those icebergs then moved down iceberg alley and may have actually had a bit of a cooling effect on that region of Newfoundland. The other thing I wanted to mention is that it looks like there's been no change in the whole Arctic area there. And that's a bit of an artifact of the fact that really the original plant hardiness formulation wasn't calibrated for areas that are that cold. So what we've done is just sort of lump that all into zone 0A on the map. But in reality, when we calculate those hardiness index values, there's actually negative values for a lot of that area. So even though there's increases there, they haven't increased up to a value of 5, where they would jump from 0A into 0B. So it's a bit, as I said, a bit of an artifact in the far north. There's definitely changes occurring up there. So just a few other signs of change across Canada. I'd mentioned that in 2014, Zone 9A appeared in far southern British Columbia. And so there was clearly an expansion there. Here it's the bright pink colors around Victoria and Vancouver. So definitely, that was really just a dot of pink on the first, or on the last update. We also had appearance of Zone 7A in Nova Scotia, appearance of Zone 7B around Windsor in deep southern Ontario. And of course, the most important change being Sault Ste. Marie going from a 4A to a 5A. Other signs of change at urban centers across Canada. I won't spend a lot of time on this, but I've already mentioned that Victoria and Vancouver had moved into that 9A zone. Lots of other regions, particularly in the west, showed full zone increases like Calgary and Winnipeg. And there's Sault Ste. Marie again. And there's also Toronto showing a full zone increase. But as you move east, you do see less of those full zone increases or even changes at all. Like Montreal didn't technically change zones, although it did increase hardiness index values. Similarly, Charlottetown didn't show a change as well. One of the new things we did with this latest update was try to get a sense of which variables were the largest drivers of change across Canada. And the results overwhelmingly pointed towards several variables closely related to temperature. So specifically across the middle part of the country in the dark blue, that was the biggest driver of change was variable X1, which is minimum temperature of the, average minimum temperature of the coldest month. And on the edges of Canada, on the east and west ends of the country, the light blue variable there was frost-free period. So we seem to have sort of different drivers, but both kind of not surprisingly, I guess, temperature-related variables. And actually, these findings are backed up by other climate change trend studies that have been carried out in Canada. And I've also found that there's been big change in relation to minimum temperatures across that sort of prairie region, with larger changes in growing seasons towards the edges of the country. So these zone changes do have implications for growing opportunities. There's some different scales to a statement like that too. Small scale, it could just mean being able to grow a new plant in your backyard garden. But scaling up, there's also implications for agriculture, particularly fruit production. And I've shown a few examples of either fruits that are already growing in regions or are potential for locations across the country. I know there are already figs being grown near Comox on Vancouver Island, and there's excuse me, drink break. There are reports of hardy citrus crops, outdoor trees that aren't sort of brought in and out for the winter season, although there is still some TLC needed to grow citrus even in the Victoria region. But it does appear to be happening, and it's actually a former CFS employee at the Pacific Forestry Center that is doing that, a man named Bob Duncan. When we move into the prairies, then of course we get much lower hardiness zones there. And in southern Saskatchewan, there are varieties of apricots that are suited down to zone 4. There's certainly apples being grown in the southern part of Manitoba. Honeycrisp would be a bit of a stretch, but I know there are people trying it. In far southern Ontario, in that zone 7A, 7B, there are reports of people trying hardy varieties of pomegranates. I don't think there's going to be any pomegranate orchards anytime soon there, but it is happening in a small scale way. In southern Nova Scotia, it's not even a stretch with peaches. I think those are already being grown there, and the increase in hardiness zones will probably just make it more comfortable for peaches in that area. And it's not all just far southern locations, of course, that would have some new opportunities. I'm also showing an example with sour cherries in a zone 2B area in central Saskatchewan. And there's a number of different sour cherries that will grow in down to zone 2B that have been developed at the University of Saskatchewan, actually. And they have colorful names. They're part of the Passion series, and they have names like Crimson Passion and Romeo and Juliet. So some fun sour cherry opportunities in that region. And then again, returning to the center of the universe, Sault Ste. Marie. I'm proposing that pawpaw might be a potential species for our region. Yeah, I think of it as more of a zone 6 plant, but there are apparently hardy varieties that are being developed, and we're sitting around a 5A here, so it's kind of borderline for pawpaw. For all I know, people are already growing them, but if you are, please let me know. It's good to keep track on what's happening around the country. This is a favorite article of ours around here. It's from 20 years ago in the Sault Ste, and it fits in with this conversation about new growing opportunities as the zone change. And this is an article about a man who had successfully grown a peach tree in the western part of Sault Ste. Marie, the western part of the city, and the article mentions that this fruit bearing had been preceded by a number of winters, a number of mild winters, and that the yard where this tree was being grown is sheltered. So that probably helps explain why he had some success. But what's not mentioned in the article is that 5 years later the tree died. So it got hit by a cold, an extremely cold winter, and there was a lack of snow cover to kind of protect the roots. So I guess it's a bit of a cautionary tale about pushing the envelope and trying to grow things outside their zone. I'm not aware of peaches being grown currently in the Sioux, but my guess is there are some people trying it, and I would guess there's maybe a bit more success even now than there was then. So these shifting zones, though, they don't necessarily, of course, translate into new opportunities. We increasingly hear people. Well, I guess they're unhappy about the situation, in that a common thing we'll hear is that your map is saying that our zone is increased, but I'm having trouble growing the old stuff here, let alone some novel species. And there's a few reasons for that. Certainly one of them is that there's good evidence that climate change is bringing more extreme weather with it. We hear about droughts and heat waves and late frosts. And this example I'm showing here, I won't go into a ton of details. It was something we published with our 2014 plant hardiness update. But the top line here, which has a slight negative trend to it, and is associated with the right axis here, is showing the predicted emergence date of maple leaves, and it's declining. So it's meaning that the conditions are right for maples to unfurl their leaves earlier in the season as we're going through time here. The bottom line is showing the risk of a fall spring event, and we can see that's increasing through time. So there's a bit of a perfect storm here for maples, as they're encouraged climatically to maybe leaf out a bit earlier, but there is a higher risk of those early leaves getting hit by frost. And there certainly have been examples in recent years, certainly the last decade, of some pretty extensive late frost events. The other thing with shifting hardiness zones is that it's not just the hardiness zones shifting and the southern plants shifting, it's also the pests that come with them. And there are certainly plenty of pests that seem to be on the move with climate change. These include species moving northward into Canada and species moving around within Canada too. So I've got a few of them shown here, including spotted lanternfly, which is kind of just on the verge of coming into Canada from the south, and seems to focus on a few tree species, particularly the tree of heaven, and which is not native to Canada, and it does harm a number of agricultural crops, including grape crops. So certainly grape producers would not be happy to see this animal arrive. Oak wilt, of course, focuses on oaks, emerald ash borer, ashes, mountain pine beetle, pines, and the brown marmorated stink bug, which is also moving into Canada imminently, is a pest of uh, fruit trees such as apples and peaches. If you're interested in this kind of topic, we've developed quite a number of climate habitat models for forest pests for current and future time periods at the website I'm showing here. So I'd like to talk a little bit about future projects, some plans for future work. A few decades ago, the American Horticultural Society produced a plant heat zone map, such as the one shown here, and we thought it would be interesting to develop something similar for Canada. It should be a relatively straightforward map to develop, and it's something we'd hope to do in the near future. Another thing that we're thinking about is looking at different time periods for the climate variable summaries. I mentioned that it's the original work made use of 30-year climate normals, and we've stayed faithful to that original approach, but we are intrigued with the possibility of using shorter time periods, which would give a bit more flexibility for doing updates and being able to show what's happening, sort of more immediately. With 30-year time periods, certainly one of the things we hear from people is, why don't you do more updates? But when you're working with 30-year time periods, I mean, we've been doing basically 10-year updates, and even at that, you're overlapping by 20 years when you do an update. So the change is pretty minimal, actually, even with updates every 10 years. But if we were to shorten down those time periods, we would get a better sense of change associated with climate change. So it's something we're looking into. We also hear, questions periodically about whether there's maps for future time periods, and there aren't at this point, but it's something we're looking into. Some of those 7 climate variables are not particularly easy to generate for future time periods, so it's not something that's happened yet, but and it would take a bit of work to do. And finally, another thing we hear about is, is it time to develop a new hardiness equation? This equation was developed almost 60 years ago, and it may be time to start that process again and look at incorporating some climate variables that maybe better reflect some of the challenges with growing plants under current climate conditions. I would say that wouldn't be a small undertaking. The original work by Willett and Shirk, as I mentioned, was nationwide, involving hundreds of locations and hundreds of plants, and I think you'd want to have at least that many, probably more, to redo this. So the last topic I'd like to mention is what might be considered an alternative approach to plant hardiness mapping, and these are some of the species-specific models we have at our website that's provided at the bottom of this slide. And with this work, what we've done is gathered together occurrence data for many plant species across North America, and then we've merged that with the climate data I talked about us developing. And that allows us to generate climate envelope or climate habitat models. And we've done that for about 3,000 different plant species, all of which are available at the website. And one of the nice things about this approach is it allows us to fairly easily incorporate future climate projections and show where that climate habitat is expected to shift in the future. A few more things about the website. At the website, you can select and search for a plant of interest. You can also select your time period of interest, your mission scenario, and model of interest, and the maps here to show a climate habitat for sugar maple for the 1971 to 2000 period, and where that climate is projected to shift for the 2041 to 2070 period under a middle of the road emission scenario. The other thing I wanted to mention is we have a function there at the website that we call Plants in My Area, where users can provide their municipality and select a time period of interest, and then they will get a list of plants that are potentially suitable for that location and that time period. So kind of, could be helpful for people who are looking for some inspiration about what plants to plant, both under current conditions and potentially future conditions. And I presented this portion of our work as, a potential substitute for plant hardiness zone maps. And there would be some pros and cons to doing that. Certainly with the species-specific models, it's kind of like a customized hardiness zone for each species. So it allows more details for any given species about where it might be able to grow. I think the biggest challenge, though, is that, I mentioned that we've developed this for about 3,000 plant species, which maybe sounds impressive in some ways, but there's about 50,000 plant species in North America. And that's not even counting all of the horticultural varieties, which would really be the main interest in some cases for some groups anyway with this work. So there would be a lot of work still to do to make this a viable option to the generalized plant hardiness maps. All right, well, that brings us to the end. I hope I haven't gone on too long here, but just to summarize then, hardiness mapping has been going on in Canada since the 1960s, and GLOC has been involved really since the mid-1990s, thanks to Dan's work in that area. The hardiness zones have changed over the last 30 years, and in some cases, the changes have been pretty dramatic. And on the plus side, I guess, it's every now and then it's nice to not necessarily focus on the negative side of climate change, but there are some new planting opportunities at locations across Canada. But the reality is that the extreme climate and associated pests are likely going to limit the amount that people can actually gain in that area. And just close by saying that the species maps, the plant hardiness maps, are all available at the website listed there. So thanks for listening, and I will stop sharing my screen now.
That's great, John. Thanks so much for a great presentation. We'll open it up here for questions in just a second, and you can put your hand up and ask a question, or you can go in the chat, or you can just unmute yourself and ask John a question. Before we get to that, if some people head out, I just want to mention when our next webinar is going to be, and that's going to be on October 29th, so the last Wednesday of October. And Guy Smith and Ruth Koskanoya are going to present on the Algoma Envirothon program. It's the 30th anniversary of the program this year. So I see a few hands went up. Who do I see has got their hand up? Did I see? Oh, yeah. Okay, Rob's got his hand up. Yeah.
Oh, dear. Yeah, hi there. Excellent presentation, John. And you think you got problems with modern technology? Yeah, well, here I am.
There's Rob. That Rob. Oh, okay.
So
Hi, Rob.
I'm just wondering if you can talk a little bit about the relationship between macroclimate and microclimate, and how might one use the plant hardiness zones when considering microclimate?
That's a good question, Rob. Yeah, I guess my mind goes when I hear you say that, I think of the fact that the plant hardiness zones don't do a very good job of dealing with microclimate. They really are sort of a mesoclimate a phenomenon that's being used for that. So we're encouraging, we always encourage users to look at it as think of it as a general guide. I know some people sort of hold on to it like it's the gospel truth, but it really is a general guide, and a lot can happen below the scale of what those maps are predicting for a location. And to mention a few obvious ones, yes, the microclimate, be it because of microtopology or exposure associated with building. I had some other thoughts on that, but they're quickly disappearing. But yeah, that's my main thinking. Is I think it's important that people realize that microclimate isn't part of these plant hardiness zones.
Thank you.
Is that consistent with what you were thinking, Rob? Or?
Yeah, I think so. As you said, topography is one thing, exposure is another. There's various aspects, the type of soil or the type of vegetation.
Right. That's the other thing I was meaning to say, soil. Yeah. Okay. Thanks.
Yeah, Dave Pearson here. Can I just very much agree with that? We have close to us, within about 5 kilometers, 2 locations where magnolias grow very nicely. Both of them protected. One of them is near it's in the grounds of a church, and it's sheltered from winds coming in from the west. But in a corner, and there's another one close by, a beautiful yellow magnolia actually, and we love to see it as a sign of coming warmth, budding out with its leaves. And it also is sheltered, very sheltered, close to the wall of a house that also shelters it from the western winds. And I remember being up in Sandy Lake, that's in the northwest, and about 5 or 6 years ago now, and there was a woman there who was growing grapes and peaches. She had a peach tree and grapes that now I don't know how long they survived. They might have been like the peach tree that you talked about, but it was quite astonishing what she was able to achieve. And her ground wasn't sheltered in any significant way at all. There were trees, some 20 or 30 meters away, but she just had to go, and my goodness, she had grapes. Growing. I didn't see any peaches fruiting, but certainly the grapes did. I do have a question, John. Have you noticed any effect of the greater curvature, the waviness of the jet stream? There was a time in, I think, 2012 when the temperature in Fort 7 up on the Hudson Bay coast was the same as in Phoenix. And the folks in Texas have had cold air coming down and snowing, and they don't have snow tires, and it's just desperate down there when that happens. And I suppose perhaps those are so short term, a week or two or thereabouts of cold, or exceptionally cold or exceptionally warm, that they don't make a difference to the zone.
Right. No, that is a good point. There's a few things there, I would say. I've also noticed, I mean, maybe not so much the last couple of years, but over the last decade, it does seem like these outbreaks of cold air seem to be more frequent and more intense, particularly, well, I was going to say in the eastern part of the country, but there's plenty of it in the western part of the country also, and again, like, that's not necessarily going to be picked up in that 30-year average of the plant hardiness zones, especially if it's something that's been happening fairly recently, when you're averaging over 30 years. So I do think that that's not necessarily captured in the index. But another sort of interesting thing we've noticed is that despite these changes in the hardiness zones, which haven't been that drastic everywhere, but we're certainly not seeing farmers making big changes in the crops that they're trying at their locations, not in a big way anyway. There's some changes going on, but I think that farmers are still really aware of the element of risk here from things like those extreme cold events that are happening these days, and they're pretty reticent to make big changes. So I think I think even if the maps aren't showing it, I think it's actually kind of showing up in people's decisions around plants still, that they're being pretty risk averse, I think.
Yeah, perhaps I should add for people, I'm in Sudbury, so those magnolias are
right.
are really pushing the envelope.
Yeah.
And if I may, just one very quick point, I noticed on the map that showed cooling as well as warming, that there are two tiny little blue patches up near Webequie and Nibinamik up in far northern Ontario, approaching Hudson Bay. That those
right.
two little cool zones. Any explanation for those?
I haven't looked into those in detail. I don't know that. I mean, I could check right now, but sometimes I'd mentioned how there's almost artifacts the way some locations haven't changed the zone, but they've increased in their index value, right? But they just haven't jumped over that magical threshold into the next zone. I mean, in other cases, you might get a place that's just barely changed at all, but it happened to fall below that threshold. It might have declined by 0.1 of a index value. I could. What were the locations you said, David?
Well, they look to be up around a couple of 100 kilometers south of Hudson Bay, sort of central far north, near Webequie and Nibinamik, I think, up in that neighborhood.
I'm not sure that those are going to show up in our database.
Well,
I don't. Webequie. Well, there you go. Webequie says it's changed from a 13 to a 14, a very small change. So it must not be that exact location but I can look into that and get back to you on it. But that's some of those. I mean, some of those things could be some kind of an artifact too of like climate data. Also, if a new climate data or a couple new climate data stations show up at a location, so that could change it could change the underlying climate maps, which would then have an impact on the index value. So it could be that there's some new climate stations there that actually give us more accuracy in that location, and then we're able to see, okay, actually our previous estimate of plant hardiness was probably a bit off because we didn't have great climate data for that location. But I can look into some of those things and get back to you.
Yeah, which fits actually with Heather McDonald's suggestion in the chat that the far north there's just not as much data. Anyway, thanks very much, John.
Yeah, great. Thanks for the questions.
Yeah. John, can you read the chat? There's a question in there.
Yeah, sure.
Daniel Featherstone?
Yeah, he says, sorry I missed this. Does the hardiness include aquatic, submergent, and emergent plants? Are more southern aquatic plant species moving north along the Canadian shoreline? And would the mapping be consistent with the terrestrial plants, right? That's a good question. I haven't thought too much about aquatic plants, to be honest with you. As far as the hardiness zone maps go, I mean, I don't think there were any aquatic plants in the sample of species and varieties that Willett and Shirk used to develop the index. So I would say that aquatic plants aren't really part of the hardiness zone mapping. As far as the species-specific models at our website go, I know there are some aquatic plant species there that one would be able to sort of track their climate habitats under current and future climate. But hopefully that answers your question.
I've got a question about more on the forestry side on the species. And I mean, you talked about sort of an agriculture decisions being made not to be to be risk adverse, I guess, and not try to grow new crops with perceived change in the climate in a particular. What about in forestry? And I'm thinking of the assisted migration idea and different trials. What's happening right now in terms of reforestation and tree planting and so on, in terms of moving different species or provinces of different species?
Yeah, that's a good question, Paul. As far as movements go in the assisted migration context, I think there's certainly a number of provinces that are moving ahead with the assisted population migration. So that basically involves moving seed sources within the existing range of the species. Typically they'd be moving them northward or upslope, so that you're getting seed sources that are better suited to some warmer conditions, moving those northward, so that they're kind of preemptively there for the expected climate coming in the coming decades. That's sort of full speed ahead, I would say, in British Columbia and Ontario. Quebec is doing it as well, and Alberta is doing a massive overhaul of their system. I don't know if it's officially happening yet, but it's going to happen there too. So from that perspective, lots of assisted migration happening in forestry. As far as like actually moving species outside of their existing range limits, again, typically northward or upslope, I would say quite limited on that front. I think people are still a bit nervous about creating, novel ecosystems or invasive species, and my understanding is there's very little policy in place that would permit that or encourage that. I think there's something in the Canadian or in the Ontario seed transfer guidelines that may allow it with permission from the proper powers that be, but it's not happening very much. It is happening in a research context, and some of those research contexts are fairly operationally scaled. Like there's the what's called the ASK trial. I'm not sure if you've heard about that, adaptive silviculture for climate change, that's happening at Petawawa Research Forest. And that's, full on operationally scaled, tens of hectares or more, maybe hundreds of hectares of trials where they're trying different silvicultural responses or treatments in anticipation of climate change. And some of that is moving species hundreds of kilometers northward. And I know there's other big trials in the works as well, but as far as actually being part of provincial guidelines, I'm not aware of much on the species shifts.
Great, thanks.
Yeah.
Dave Pearson has put a comment in there that there's some interest in red spruce there in their re-veg program, which I would assume is on the same kind of scale you're talking about, right, David, in terms of being experimental rather than operational forestry.
Yes, I was just at the what used to be the Inco greenhouse, the Valley greenhouse now a couple of weeks ago, and they have oh goodness, several hundred red spruce to be trying on the tailings, which is their principal interest for tree planting.
Cool.
Great.
Yeah,
Well,
that's. Is anybody familiar with red spruce in the wild and in your area?
Not really, to be honest with you. I mean, it's quite hard to identify. I think from from black and white probably. So I can't say I guess I haven't actually ever seen it in the wild in Ontario, but I know it does exist here. I don't know, maybe others probably.
There's certainly some historic plantations that Al Gordon started.
Yes,
yeah, maybe
yes,
even the one in Algoma at Batchewana and around the province that had a red spruce component to them for sure. But I don't know how active they are right now, but that's a long time ago.
Rob probably knows all about red spruce. No, Rob? I guess not. Oh, he's still there.
Maybe we'll leave it there, John. I thank you again for your.
I am here. Sorry, again, in technologically challenged, so it takes a long time. But that's a long answer to say, well, to give you not much of an answer at all. I think Paul covered it. It's been planted here and there. Al Gordon, who unfortunately has passed away, was the prime person involved with that. And he has trials from Algoma through Blind River to Algonquin Park and so forth. And the person to talk to would be Dave Morris at CINFR, that's Ministry of Natural Resources, Center for Northern Forest Ecosystem Research. I figured if I said it quickly, I can get it all out in Thunder Bay.
Thanks.
Good. Well, thanks a lot, John, for your presentation. Just to add here, if anybody would like to stay on the line, we have Ashley Anthony, who's an education and engagement manager from Climate Reality Project Canada, to lead a community call where we can all discuss updates, insights, and make some other connections beyond what John's presented tonight in the webinar. And whether you're part of Zoo Climate Hub or another Climate Hub, and if you're just interested to stay on for a bit of an extended conversation, you're welcome to do that. If not, that's fine too. And again, we'd just like to thank John very much for a great presentation. John, thank you very much for taking the time with us tonight.
Yeah,
really enjoyed
pleasure to be here. Thanks for having me. Pleasure to be here, guys.
And I'll turn it over